Yeah, g'day YouTubers, Tinker O'Toole again here with another video. Today I'm going to show you how you can easily set up your grinder with the right specifications to either give a sharper point that's on your full chisel chain, or if you own a hexa type chain, how you can profile that so that you don't have to use the file. So there's all various different methods that you can use, different angles that you can use, but generally speaking, the angle that the grinding wheel comes in is about 65 degrees. On a Stihl USG grinder, that would be 25 degrees, because on an Oregon type grinder, vertical at the 12 o'clock position is regarded at 90 degrees, and when you're sitting horizontal, it's regarded as 0 degrees. On a Stihl USG grinder, 0 degrees is vertical, and this is 90 degrees. So yeah, it's a little bit different. It's the same angle, it's just that you use a different reference point. So what we're going to do next, we've got a Oregon type grinder. We've dressed the wheel. So I'm going to show you how to dress the wheel and how to try and calculate the length of this angle and what you may need. So you don't have to copy the hexa. Can if you want. Can't stop you from sharpening it. You can sharpen it any which way you want. I'm going to sort of go over what differences I've found with the different profiles. I had a profile very earlier in the piece where I actually took the top, this angle coming down, this 60 degree angle or 65 degree angle, depends on whether hexa is 65 degrees. So, you know, you could have 60. Anyway, we'll just say 65 degrees. If you look on the side plate here, so you'll find out that it comes down about 70, 80%, something like that there. I've had my V cut, which comes about right down to the edge of the side plate. So you can have a variation on it. I haven't found out that it makes a huge deal of difference if I increase that angle right down to the transition point there of the side plate. So I've found out, and if you were to look at Husqvarna X cut, they come down 1.7 millimeters, and the Stihl Hexa, that comes down 2.3 millimeters on here. So my V cut, or the latest one that I'm sort of doing at the moment, comes down about 2.1 millimeters. So I'm opting for 120 degree span. So this angle here is 60 degrees. This angle going down is 60. So that's a combination of 120 degree angle within those two angles. That adds up to 120 degrees. And we can angle that V shape slightly from 60 degrees to 65 degrees. So that's what most people are doing. 60 degrees is quite common, but 65 degrees is okay as well. So, which 65 degrees, as I said before, equates to 25 degrees on a Stihl USG grinder because of the different reference point on 0. Typically a protractor has 90 degrees at 12 o'clock position, so that's pretty common out there. Stihl decided that they would use 0 degrees at 12 o'clock position, which is fine. I understand that. And that works well for me, and I actually prefer it that way. Anyway, we'll go on to the grinding wheel setup. So this wheel I dressed, and it came up quite well. And if you're to look up in the top left-hand corner, you'll see on the digital scope that it measured around 120 degrees. So what I use to create that profile is a metal template. I've got various different metal templates, and I've got a 30-degree template. So if I put the 30-degree template in the guide rail where the chain sits, and I sit my silicon carbide grinding block on top, I get this 30-degree angle on here, or whatever I want to set it to. Now, with the 30 degrees, that means that we'll just zoom back out here, that means that the actual grinding head sits exactly on 90 degrees. So we can put this in, this 30-degree angle here, and lock that in a position. And with this grinding block, we can move this backwards and forwards and pull the grinding wheel down as we moved it backwards and forwards, and we can put an edge on that wheel, as you've seen. Now, alternatively, this is 30 degrees. Let's just say that you wanted 25 degrees. All you've got to do is just turn the back to 85 degrees, and that you've just changed the angle. Simple as that. So you can do that without a problem. And if we just zoom in there, hopefully we can get a better... If I just go down a little bit, you might be able to see this better. It's probably better that you create a template. Could be made out of cardboard, plastic, could be made out of anything. Because all you want to be sure of is that when you've got a template, see that's pretty good like that. I'm just going to try and get this wheel a little bit better angle. This wheel's probably slightly, if you have a look, as I said before, you can change the angle by tilting. That's probably more, there it is there, and that should be close to 90 degrees. Yeah, look, it's 90 degrees is about there. So it's probably a little bit less than 120, a little bit less. Yeah, it's not too bad. Close enough anyways, pretty close. So you can see that if you wanted to do some sort of hexagonal grind, that it's quite easy to do that. So what I'll do next is sort of show you this sort of angle that we've got here and how to set it up. So you know now that you use the grinding block held at a certain angle will give you the angle that you want on here. Hexa or hexagonal or top plate cutting angle, where it comes in at that angle there, is normally around 60 degrees, and as I said, hexa is 65 degrees, but you can have what you want. I would personally stick either 60 degrees or 65. It may make a slight difference, but who cares whether it's 1%? You're not even going to notice 1%. So I guess what Stihl did when they did their hexa, they all did it in a laboratory, and they found out that it was that way. But 1% in your cut-in time is not going to be a game changer. So I don't say near enough is good enough. If you want to duplicate the hexa, you've got your 30-degree plate here. That's 30 degrees on there. And if you set your grinder on 90 degrees and hold your block, you'll have a 30-degree angle on the wheel, plus the vertical. So that adds up 30 and 90. That adds up to 120. That's what you've got. And then with hexa, you set this angle to 65 degrees. That's it. And you can play around with a little bit that you'd like. So if you want to make one of these, briefly, I'll just give you the dimensions of it. So the length of it, 120 mil long, The height of it is about, it roughly comes to about 70 millimeters. And if you use a protractor and get your 30-degree angle, you can make it out of cardboard or plastic. Let's just say you made it out of cardboard or plastic. Plastic's probably better than cardboard. And if it's made out of plastic, you don't even have to hold it on here. You can just, even if you hold it a couple of millimeters off, long as you're holding it at the right angle and bring your grinding wheel down, you can quite easily do it like that because you can see the angle. So if you come down with your eyes and look at the gap underneath and try and keep it parallel with that as much as possible, yeah, you're not like that or you're not like that. You want to keep it parallel as possible, hold it like that, and it doesn't even have to touch the cardboard or plastic or whatever. So that's another way you can do it. It's just that it's easy for me to make it out of stainless steel. It'll last a long time. And as I said, you can change the angle by adjusting the head. Okay, so you've seen the wheel, you've seen the profile. So it's a 4.8 millimeter wheel in width. It's a lot of them, you know, will say they're 4.7 and they can measure a little bit different, but anyway, it measured 4.8. So what we do is we need to put a 30-degree angle on the left side of the wheel, approximately about 3 millimeters in width, and a flat of approximately 2 millimeters in length. And what that will actually do is give you this profile here of the hexa. It'll be 2.1 millimeters in length on the top plate cutting angle. So top plate cutting angle is the angle that the grinding wheel comes in at. So it's going to come in, if you set it at 65 degrees, it'll come in at 65 degrees. And approximately 2.1 millimeters in length, and the part of the hexa that goes down will be approximately 3.5 millimeters in length. So over here I measured a hexa chain, an original hexa from Still, never been used, and on the top plate cutting angle coming in at 65 degrees, we got a length on the side plate of 2.3 millimeters in length. And going down 60 degrees, we've got 3.1 millimeters in length. On the X cut, you got 1.6 millimeters on that edge there. And you've got another angle here that's fairly straight. It's got a slight sweeping angle on it. Don't think it's really that important. Okay, so let's just say that you want to change the size here. So in other words, if this is giving us a 2.1 millimeter length here, because we've got 3 millimeter length here. Now the side of the wheel, it's this side of the wheel here. We'll just get a red texture. So when we're doing a hexagonal grind, we're using two sides of the wheel. We use this side and this side. And that gives you 120 degrees because it's 60 degrees a side. Or, well, the wheel is vertical. The wheel's got an angle of 30 degrees. That adds up to 120. The wheel is vertical sitting like that. Then we tilt it over 25 degrees from 90. That makes 65. So, if you want to change, forget about the side, because, well, don't forget about it, but the side will come into the two. So the side of the wheel is this part here. And this part here, this 3 millimeters, is this length here. And we'll just bring up another screen to show you if you want to change the length. So what we've got here now is exactly the same thing, but written a little bit different. So this is the hexa tooth here. We have 25-degree angle or 65 degrees on an Oregon, same thing. So that's the angle of the wheel coming in. Now, if you shorten this angle here, so in other words, if you grind more off the bottom, then this grinding wheel will come in a bit deeper and it will extend this. So that's how you actually extend it. You grind the bottom off. So before, if we just put this back up here, don't know whether you can't see it that good, we'll have to change it. So if I'll just get that there. If you want to make that top plate cutting angle come deeper into the side plate, all you need to do here is make this a little bit longer. So in other words, this is reduced and this is increased. This will go deeper into the tooth, and in turn, by going deeper into the tooth, instead of 2.3, you may be something like that. So bear in mind also, if we actually look over here, from the top of the tooth to normally the bottom of the tooth, we're talking about a brand new tooth, by the way, not a used one, because as the top plate slopes backwards, the height gets smaller. So a brand new tooth has got 5 millimeters in height. So in that 5 millimeters in height, on an angle of 60 degrees, you've got 2.1 millimeters here and 3.5 millimeters on here. On hexa, you've got 2.3 millimeters and 3.1. So you can see as you increase this one here, this one will decrease. And you can change the height on your side plate to what you believe is good. So what's my personal opinion on the side plate? How much should you have? Well, I reckon you should have at least around the 2 millimeter mark. I've done experiments and very, very difficult to tell. I've gone right down to the side of the actual, we've got a hexa here. We'll just zoom in a bit there. We'll just get rid of this. On my grinds that I do on hexa, I believe that you only need to come up to about that point. You don't need to go much deeper. I haven't found that it makes any difference whatsoever. All companies are going to make claims saying that theirs is better than their competitor. I find they all work pretty good, but I find even this grind does work good, but certainly if you give it 2 millimeters, I don't think you'll have any trouble and it will perform well. I haven't found any great deal of evidence that this part contributes a lot, whether it's on a 60-degree angle or whether it's a bit like this. Oh, hang on, I'll try and do that a little bit better. What I'm trying to say that if you come down there and you have a little bit of a curve on here, I still think the most important part is this area here. On full chisel, on any type of hexagonal profile, or on any profile that you extend the top plate 60 degree or 65 degree angle, Normally when you hold a file on a round file, so if we have a round file, normally when the round file sits in here, if the file is at the right angle, and that's roughly about 20% higher than the tooth, you end up with a 60-degree angle at that point. By profiling the wheel, you end up with a different point on there, depends on how much that you do on the wheel. So it's not rocket science, it's pretty straightforward. Now, I can give you another thing to try if you want. I'll just wipe this off. So that if you don't want to dress your wheel up a little too much and you want to try this way, this will work good. A normal wheel will look a little bit like that, this being the half a circle. And normally you would use what you call a little dressing card, which looks a little bit like this. And you create a half a circle, so I'm pretty sure you can see that. They're all half circles on the bottom. And that normally gives you a 60-degree angle on your tooth at this point here. See whether you zoom back out and see that. So that's normally where your 60-degree angle is, provided your file's about 20% higher. So if that's your file in there, let's say your file's 5.5 millimeters. If you remember before, I told you from the top of the tooth to the bottom was about 5 millimeters. So therefore, you want about a millimeter of the file sticking above the tooth and you'll get your 60-degree point right there. Okay, so now for the simple, relative, not a major change in your wheel that will still give you a great profile. Let's just say this is your wheel, and instead of doing, if down the bottom here, where I put that little black mark, if that was your full circle, let's go a quarter of a circle. So in other words, it's not as steep. Now, let's just say for argument's sake that the distance from here to the bottom, and I've never measured it, but let's just say it's about 2.5 millimeters. Something like that. Could be a little bit more, but just say it's 2.5. And we reduce that from 2.5 to say 1.25 millimeters, half the amount. So what you're going to find out on your tooth is that this edge with its reduced, so instead of being like this, it's like that now. You're going to find out that your wheel is going to fit into the side of the tooth much deeper. And what that's going to mean, if that is your tooth there, your grinding wheel is going to sit in deeper of about, say, 2.1, 2.3 millimeters. And that's how, and a real simple way of dressing your wheel is that you don't have, if that's a half a circle, you only dress a quarter of a circle, which is a very light arc like that. So, yeah, just a very light arc. Because, and I've done this before, going back 3 years or so ago, when I first started playing around with hexagonal profiles, and it came by accident, I was dressing my wheel like that, 90 degrees, bang. So therefore, if I was coming in at 60 degrees, I was going down at about 30 degrees. That's a right angle. And that worked fine. It wasn't until I saw Hexa And I thought, wow, that looks like mine. That's how I came across Hexa, because I was just on the internet and still were advertising Hexa, and said, wow, I came across this by accident, because what was happening, I hadn't dressed my grinding wheel for about 4 years. So if the grinding wheel was half a circle from brand new, it sort of looked a bit like that by the time after 4 years. And that's what gave me a slight bit of a hexagonal profile. And yeah, I just came across it by accident. Now, look, I wouldn't be surprised if a lot of these angles all come across by accident. That's how a lot of people find things. That's how Joseph Cox got the idea of watching that special beetle, that grub that was using its jaws to cut through the timber, and he came up with the idea of the full chipper chain. So somebody maybe had done the same thing, roughly what I did on their grinder, and said, oh, that's a different profile. Maybe they started to experiment. But I'm sure a lot of companies did a few experiments, and the most common profile that I see on a lot of full chisels is a very, very similar to the Husqvarna, where it has a little tiny point like that. So it may even be 1 millimeter's fine. Even if it's 1 millimeter point, it's going to work, because on the top plate and on the side plate, you're getting like this spear. If you imagine an arrow, a spear. So this really digs into the timber. And even by having 1 millimeter, it's going to start the splitting process or cutting process and get the chip out of there. So this really does work good. Just got to be careful. It can be blunt. So I'm going to do a lot of trials on time-based and all different profiles, and I'll publish them. And I don't expect to get anything exciting. I think the difference between full chisel and Hexa, it's well known that it's roughly, Hexa's about 10% faster. So if I'm only getting 6 or 7%, a lot of companies are not going to publish a lot of information if they're only getting a few percent difference between one chain and another chain. But if you get 10%, that's worth publishing. Anyway, I hope that helps. I've given you the ideas on how to use a grinding wheel. Now, the only other thing that I probably didn't mention, that when you are measuring the profile, I use a digital vernier caliper. That helps me to determine that if I'm going to measure a tooth, what this distance from here is. So that helps really good. I measure about 4 or 5 times and just take an average of what I get, and that seems to work quite well. Certainly good enough for this experiment. Anyway, thanks for watching. Give us a thumbs up. Bye for now.